You now have a little bit of experience working with word problems that ask you to build a proportion or percent equation to solve them. So we're going to review the different types of word problems that you will see that require either a proportion or a percent equation. The first one is the tax problem. When dealing with taxes, we remember that the amount paid in tax over the original value equals the tax rate over 100. So in other words, the amount of sales tax you pay depends on the total price tag of the item you're buying or the item you're selling. And then the tax rate is the percentage out of 100 that sales tax comes from. So, in a word problem that looks like this, Mr. G paid $240 for a lacrosse stick. The tax added to his final bill was $11.04. What was the tax rate? Well, really then what we're asking is 11.04 is what percent of 240? Because 240 is the original value before we put taxes in. And $11.04 is the tax value. So that $11.04 has to have come from some percentage of the original value. And that's why we build the equation as seen. 11.04 over 240 equals x over 100. We solve that, we get x equals 4.6. Remember, it's percent, so x equals 4.6%. Now, a new one that we'll see is based on commissions. So the first thing you might want to ask yourself is, what is a commission? A commission is, well, I'll give you two examples. First one here is someone who sells cars. They work for some sort of hourly wage, let's say, but they get a bonus per car they sell. So the $1,000 would be a commission per car sold. So if they work for 4 hours, they get $40. But if they sold 2 cars in those 4 hours, they get an additional $2,000. Another way, and one that will be more like what you'll see for your word problems, is that a person sells something, let's say encyclopedias in this example, and earns a 10% commission on every sale. So in other words, he doesn't make any money, or she doesn't make any money, unless she makes sales, or he makes sales. And the sales in this case, the example I gave was that if they make 10% every sale, well, let's say they sold $100 worth of encyclopedias today when they went from door to door selling encyclopedias. Well, they'll make $10 at the end of the day based on the commission that they earn on the total sales that they make. So we're going to be able to figure out what that commission rate is. It's kind of like the tax rate. What the commission amount that they earn, it's kind of like the sales tax earned. And the original value, which is the amount sold. So if you look, these problems are going to have a very similar pattern every single time. Let's look at an example of commissions. The commission rate for a saleswoman at Harry's Hubcap World is 16.5%. If the saleswoman sells $499.95, so $499.95 worth of hubcaps this week, find the commission she earns. Take a moment and think about where everything will go. Is that $499.95 the whole amount? Or the commission she earns? Is that 16.5% representative of the commission she earns or the whole amount? Well, once you put down your proportion, remembering what each piece is, remember we talked about this, is the commission earned over the total sales made equals the commission rate over 100. We see that we know that we're trying to find the commission earned. It's based on what the question asks us. We also know that $499.95 is the total sales made or earned at the Hubcap store this week. So that goes on the bottom. And then the commission rate was 16.5%. So we're going to earn 16.5% of $499.95. When we do the math, we cross multiply, get the cross products. We find that 82.49175 equals X. So the saleswoman earns a rounded version of that, $82.49 in commissions. So that was the part of the whole amount of sales based on 16.5% being the part. Now our third problem type you'll see today is the percent increase or decrease, or the percent of change problem. Now these are a little bit different. So the first two had very similar structures in their proportions. This one still has a proportion, and it still is part out of whole equals percent out of 100. But now we're going to talk about this thing called change in amount. So in other words, I'm going to have to give you a beginning amount and an ended amount, and you're going to have to find how that amount has changed from the beginning to the end. Let's look at an example. Well, before we get to the example, you might see this. I write down this delta symbol, the triangle. The delta symbol means the change over the original amount equals the percent out of 100. Remember, the original amount is always on the bottom. So, let's look at this. Mr. G used to make 25 Valentine's Day cards for his friends. Unfortunately, he now makes a measly 18 cards. What is the percent change in Mr. G's card production? Well, first thing we got to think, was this a change in terms of a percent increase or a percent decrease? Well, when you look at it, we went from 25 to 18, so that's a decrease. So now we know we're looking for percent decrease. In actuality, it doesn't change the problem one bit, but we need to know the type of answer we're going to give. This is a percent decrease answer. So I look here. The change went from 25 to 18. So in other words, there was a 7 card difference from the beginning to the end, from the beginning amount to the end amount. So my new proportion would be the change in the amount, which is 7, from the beginning to the end, over the original amount, which is 25, equals x over 100. And when I cross multiply, I find that x equals 28. So in other words, we can say that there was a 28% decrease in my Valentine's Day card productivity. Let's look at another example. Reed used to sleep 6 hours a night. Now he sleeps 10 hours a night. What is the percent change in Reed's sleeping habits? Well, let's ask ourselves, are we increasing my sleep pattern or Reed's sleep pattern, or are we decreasing Reed's sleep pattern? We're going from 6 to 10. Well, that's an increase. So we know we're going to do a percent increase. We're still going to handle the problem the exact same way we did before. We're going to find the change from 6 to 10. That was a 4-hour change, and we're going to put that over the original amount. 4 over 6 equals x over 100. So you put the change over the original. So 6x equals 400, and x equals 66.6 repeating percent. Well, we have to change that. We don't have to change it, we have to add the percent sign, I should say. Reed has seen a 66 2/3% increase in sleep time. So that's a positive benefit for both you in getting the problem right, and for me in sleeping more because my son is sleeping more. Now let's do our last example. Discounts. This is the last problem type we're going to talk about today. Discounts. Same concept. The discount is a difference or a change between the original price and the sales price. So it's modeled the same as the percent increase and decrease problem. The difference in the original price and the sales price over the original price, again, it's over the original, just like percent change. It's over the original value, equals percent over 100. So let's look at this example. Shannon's new shoes cost $150, but she found them on sale for $125. What was the percent discount on her shoes, the ones on sale? So we say, well, wait a second. There was a change. There was a difference or a discount of $25 off from the original to the sales price. So with that difference, I can build my proportion. The change in the amount over the original amount, which was $150, equals x out of 100. I can then solve that proportion and say the discount rate on the shoes was 16 2/3% off the original price. So again, it's the same process. Find the change in the amount and put that on the top over the original amount and make that equal to x over 100. So that's the end of our lesson for today. You're now to go into your textbook and work on some practice problems. Should you have questions, please ask, but I encourage you to look at this video again in case you need a little bit more review. These examples are pretty comprehensive. You won't see anything too different. However, you may end up seeing different pieces of the proportion that need to be solved. So for instance, you may see the need to find out what the change was. So you'll put the x over the original price, and then you'll have a percentage value like 30% over 100. Just depends on what's given. So be aware for the slight changes, but the proportions never change in structure. So it just depends on the numbers that are given to you where they go. But the structure of the proportion will always be the same. You have two different types here: discounts and percent increase and decrease. They're kind of the same idea, remember? Change over the original equals percent out of 100. And then taxes and commissions. Kind of the same thing. The amount that you pay in commissions or tax over the original price of whatever it is that you're buying or selling equals a percent out of 100. So good luck. Ask lots of questions should you have them. and I will see you next time.